In previous lecture, I already discussed two examples of checking validity of the argument by using rule of inference, example 3 and example 4. Today I will discuss resolution. Resolution is one rule of inference. I already discussed resolution during rule of inference first lecture, where I discussed rule of inference based on the propositional logic. Computer programs have been developed to automate the task of reasoning and providing the theorem. So many of it uses the resolution. Resolution is P or Q and negation P or R implies Q or R. So if P or Q is true and negation P or R is true, then Q or R is true. Let P is true and Q is false. P true means negation P will be false. As negation P or R is true, so R must be true. So when P value is true, Q value can be true or false. Now Q or R. So Q is false, false or true, it will be true. In case of OR, if both are false, then it will be false, otherwise it is true. If both are true, it will be true, or if either one is true, it will be true. So from this we conclude that either one or both from Q and R can be true. So if P or Q is true, negation P or R is true, then Q or R must be true. That is our resolution. So the final disjunction, that is Q or R, called the resolvent. Let's solve some example. Example 5. Use resolution to show the hypothesis Jasmine is skiing or it is not snowing, and it is snowing or Bart is playing hockey implies Jasmine is skiing or Bart is playing hockey. So first I will take some propositional variable. Let P equals to it is snowing, Q is Jasmine is skiing, R is Bart is playing hockey. Now first statement, Jasmine is skiing or it is not snowing. So Jasmine is skiing is Q or it is not snowing. So negation P or Q. You can write Q or negation P or negation P or Q. It's commutative. Next, it is snowing or Bart is playing hockey. It is snowing is P and Bart is playing hockey is R. P or R. So negation P or Q and P or R are true. Implies Jasmine is skiing or Bart is playing hockey. Jasmine is skiing is Q, Bart is playing hockey is R. So Q or R. So this is according to resolution. This is valid. Jasmine is skiing or Bart is playing hockey. Next example 6. So that the premises P and Q are R and R implies S implies the conclusion P or S. So first we need to expand this. We can use the distributive law. So P or R and Q or R according to distributive law. Next, R implies S. We know P implies Q, that we can write as negation P or Q. So here R implies S, that we will write as negation R or S. So we have P or R is true, then negation R or S is true. P or R is true and negation R or S is true. So from these two we can conclude that P or S is true according to resolution. In today's lecture I discussed resolution. In next lecture I will discuss fallacies. If today's lecture is helpful for you, please like, share and subscribe. Thank you.